Imagine a planet which is created by humans. Sounds good, huh? But it is not easy. Let's dive into space. Hello guys, I am your narrator. In this video, I will tell you about rebuilding a destroyed planet. Let's go. Let's explore terraforming on a fundamental level, taking into account every aspect of the process, from scientific principles to advanced theoretical strategies, as well as potential societal and ethical consequences. Every single detail matters when it comes to creating a new Earth, and we need to grasp the full magnitude of these challenges. We will go beyond the basics and look into real-world scientific concepts, the limits of current technologies, and unforeseen consequences. What is terraforming? Terraforming is the concept of transforming the atmosphere, surface, and environment of a planet or moon so that it can support Earth-like life. This means adjusting not just the chemical composition of the atmosphere, but also modifying the planet's temperature, water sources, soil, and ecological systems. In theory, terraforming could allow humanity to expand into space by creating habitable environments beyond Earth. Key elements of terraforming: atmosphere. It must have breathable gases like oxygen and nitrogen and the right pressure to sustain life. Water. Liquid water is vital for life. Without it, no Earth-based organisms can survive. Temperature. The temperature must be regulated within a range suitable for life, 0 degrees Celsius to 50 degrees Celsius, allowing for liquid water and biological processes. Soil. Soil must be fertile and capable of supporting plants, which in turn support the food chain. Why terraforming is so complex? Terraforming is an immense challenge due to the fundamental laws of nature, chemistry, and physics. We are talking about altering a planet's entire environment, which involves many interconnected processes that influence one another. If one part of the system goes wrong, it could undo the entire effort. This is where complex systems science becomes essential. Challenges in terraforming: gravity and atmospheric retention. For a planet to retain an atmosphere, it must have sufficient gravity to keep gases from escaping into space. Mars, for example, has only 38% of Earth's gravity, which means it cannot easily hold onto a thick atmosphere, especially given its weak magnetic field. Venus, on the other hand, has Earth-like gravity, but has lost its original water to space, which could make it more challenging to terraform. Extreme temperature variability. Mars has a cold desert environment with temperatures averaging around -60 degrees Celsius, while Venus is essentially a hellish furnace with temperatures of 460 degrees Celsius. If you cannot find a way to stabilize temperatures, a planet will be uninhabitable. Creating artificial suns or solar mirrors to redirect heat is one theoretical solution. However, even this would require enormous infrastructure, possibly in the form of space-based reflectors, toxic atmospheres. Many planets have atmospheres made up mostly of harmful gases. Venus is dominated by carbon dioxide, while Mars has barely any atmosphere to speak of. Both planets require atmospheric engineering to make them breathable. Methane, nitrous oxide, or carbon dioxide need to be reduced or adjusted to create a balance with life-sustaining gases like oxygen and nitrogen. One possible method is introducing photosynthetic organisms that can convert carbon dioxide into oxygen, mimicking the process of Earth's biosphere. Lack of water. The presence of liquid water is vital for life. Without it, we cannot have Earth-like organisms. Mars has evidence of past liquid water, but lacks sufficient pressure and atmosphere to maintain it in a liquid state. Melting ice caps using greenhouse gases or bombarding the planet with water-rich asteroids could be options, but both methods would take hundreds of years to achieve meaningful results. Soil fertility. For plants to grow, they need fertile soil. Mars, for example, has soil with toxic compounds like perchlorates, which could make it hard for Earth plants to grow. Microbes and fungi that break down rocks and organic materials could be introduced to create fertile soil. These organisms would perform nitrogen fixation, turning the soil into a rich, biologically active environment. Artificial biospheres and greenhouses could initially be used until the surface environment becomes stable. The stages of terraforming: theoretical steps. Terraforming would occur over several centuries or millennia, not in a single generation. The idea is to approach it in stages, each one laying the groundwork for the next. Stage 1, preparation. Goal: make the planet more conducive to human life. Process. Start by introducing basic organisms like bacteria, fungi, or algae that can withstand the harsh environment. Artificial warming through nuclear bombs or orbital mirrors to increase the planet's temperature. Introduce greenhouse gases to thicken the atmosphere, starting with carbon dioxide and methane. Stage 2. Stabilizing the atmosphere. Goal: make the atmosphere breathable for humans and plants. Process. After raising the planet's temperature, the next task is thickening the atmosphere and making it stable. Photosynthesis organisms like algae and genetically engineered plants will convert carbon dioxide into oxygen. Special aerosol generators could be used to cool Venus or manage solar radiation. Stage 3. Creating water bodies. Goal: generate liquid water, either from ice or asteroids. Process. Use solar mirrors to melt ice caps and release frozen water. Asteroids or comets could be redirected to impact the planet, providing water-rich materials that contribute to forming oceans. Artificial lakes or reservoirs can be created for early settlement colonies. Stage 4. Ecosystem engineering. Goal: create a thriving, self-sustaining biosphere. Process. Once the atmosphere, temperature, and water conditions are stable, plants and then animals can be introduced. Start with simple plants, then move to more complex organisms like insects to create a balanced food chain. Over time, landscapes will evolve, creating a biosphere that can support human life. Stage 5. Long-term sustainability. Goal: ensure the planet can sustain human life indefinitely. Process. Gradually decrease artificial support and let natural processes take over, maintaining the carbon and nitrogen cycles. Introduce human settlers in phased colonies as the environment becomes increasingly Earth-like. Finally, ensure the planet has a self-regulating climate that can adjust for solar fluctuations or cosmic events. The societal and ethical issues with terraforming. As much as terraforming could provide hope for humanity's future, it raises profound ethical, philosophical, and societal questions. Ethical considerations. Planetary protection. Should we terraform a planet that may have potential for alien life? Could our actions wipe out life that might exist in microscopic form? We might be unintentionally violating the principle of non-interference in extraterrestrial ecosystems. There is the argument that humanity's survival should come first, but we must balance this with respect for other worlds. Resource allocation. The resources required for terraforming would be enormous. Should we spend trillions on making another planet habitable when we have pressing issues on Earth, such as poverty, climate change, or overpopulation, to resolve first? Some argue that saving Earth should be our first priority. Others believe that by investing in space colonization, we are ensuring humanity's long-term survival. Sociological impacts. Terraforming may have unintended societal effects. If we build new Earths, how do we prevent inequality and ensure fair distribution of resources? Would it result in new forms of colonization, or could it create class divides between Earth and those living in space colonies? Human impact. Would humans begin to overuse these new planets, repeating the same environmental mistakes they made on Earth? A new planet may offer opportunities for growth, but it could also lead to worse exploitation if humanity doesn't learn from its past mistakes. Conclusion. Will terraforming be our future? The concept of terraforming Earth 2.0 is both exhilarating and daunting. It represents hope for humanity's future, a future where we transcend our limits, survive beyond Earth, and ensure that life continues. However, achieving this vision will require immense scientific innovation, international cooperation, and perhaps most importantly, an ethical commitment to ensure that our survival does not come at the cost of other worlds or the long-term health of the cosmos. Terraforming might be the key to the future of human civilization, but only if we proceed with a deep understanding of the technical challenges and the broader consequences of altering an entire planet's ecosystem. Would you like to dive deeper into any specific aspect of this theory? Whether it's the technological methods, real-world progress, or ethical debates, there's a wealth of discussion to explore. Thanks for watching. Like, share, subscribe if you like my videos.